In this second video on number theory, we're going to talk about greatest common divisors or factors, sometimes called GCFs, and also least common multiples, which we use LCM for short. So let's go ahead and get started. So it says the greatest common divisor or factor is the largest number that divides two or more natural numbers. So for example, if you wanted to find the greatest common divisor or factor, GCF is probably the most common way that people say this. You first can look at the factors of 42. So let's see, certainly 1 is always going to be a factor, and this is an even number, so 2. 42 is divisible by 3. Notice 4 plus 2 is 6. 6 is divisible by 3, so we know that 42 is. And let's see, the next number would be 6. Of course, 6 times 7 is 42. So 6 and 7. Now at this point, you can see that they're going to pair up. You have 6 times 7, and 3 and 14 would work. So 14 and 2 times 21 and 1 times 42. So you have 7, 14, 21, and 42 as the last numbers there. For 70, you have 1, 2, 3 doesn't work, 4 doesn't work, but 5 does, and 7, and then as we know 7 times 10 is 70, 5 times 14 is 70, 2 times 35, and 1 times 70. So there's all your factors of 70. Now we're looking for the greatest common factor or divisor. Well, the largest one, in fact, would be 14. And so our GCD or GCF here is 14. So if you know your divisors well and the numbers aren't too big, this works pretty well. And this is how most people find a greatest common factor. But as the numbers get bigger, this can be more difficult. And so I'm going to show you how you can use the prime factorization of two numbers to help you find the GCD or GCF. So the first step is to prime factor each number and write without exponents. So that is correct. We're going to write without the exponents when we do the prime factorizations. Step 2, the GCD is the product of the factors that the two factorizations have in common. So that word common and greatest common factor helps me to remember what I'm going to do here. I'm looking for what factors that they have in common. So let me show you how this works. So for 54, again, 6 times 9 is 54. We can break 6 down into 2 and 3, which are both prime. 9 is 3 times 3, which are both prime. And we can do the same thing with 72. So 72 is 9 times 8. And neither of those are prime, but 9 is 3 times 3, which are both prime. 8 can be written as 2 times 4, and the 2 is prime. And then 4 can be broken down into 2 times 2, which are both prime. And so 54 is written as 2 times 3 times 3 times 3. So again, we're not going to use exponents here. And 72 is 2 times 2 times 2 times 3 times 3. Notice that we have a 2 in common, only one though, and they both have at least 2 3s, so 2 3s in common. So these are the factors they have in common, 1, 2, and 2 3s. And so our GCD or GCF is 2 times 3 times 3, which is 18. All right, so if you think you've got it, I would encourage you to do B and C. If not, watch another example and then try the last one. All right, so on B, if you prime factor 48, let's go with 6 and 8. 6 is 2 times 3, which are both prime. 8 is 2 times 4, the 2's prime. And we can break the 4 down into 2 times 2. For 56, that's 7 times 8, and 7 is prime. We can break down the 8 into 2 times 4, and the 2's prime. And we'll get 2 prime factors of 2 from the 4. So 48 can be written as 4 2's multiplied times 3. Again, we're not using an exponent here. And 56 is 2 times 2 times 2 times 7. And so you can see that we have 3 2's in common, 3 factors of 2. And so that's going to be our GCF. 2 times 2 times 2, which is 8. All right, on letter C here, 7 times 9 is 63. The 7 is prime. We can factor 9 into 3 times 3, which are both prime. Let's see, 84 can be written as 2 times 42, and 2 is prime. The 42 can be written as 7 times 6, and 7 is prime. And 6 is 2 times 3. And so 63 is 3 times 3 times 7. And 84 is 2 times 2 times 3 times 7. What do we have in common? Well, they each have a factor of 3, and they each have a factor of 7. So 3 and 7 are common factors. And so our GCF is 3 times 7, or 21. All right, so that's how you find a greatest common factor or divisor. Let's look at LCMs next, or least common multiples. It says the least common multiple is the smallest multiple that two numbers have in common. So for example, if we had 6 and 8, and I wanted to find the least common multiple, the multiples of 6 are 6, 12, 18, 24, 30, and so on. The multiples of 8 are 8, 16, 24, 32, and so on. And you can see the smallest that they have in common is going to be 24. Now, if we kept going, you would find that there are others that they have in common, but we're looking for the least common multiple, and that would be the 24. All right, so now that's the way we normally will do it if the numbers are small, but we can use the prime factorization in the following way to find the LCM. So step 1 is to prime factor each number and write with exponents. So notice with LCM, we're going to write our prime factorizations with exponents. Number 2 says the LCM is the product of each prime factor found to the highest power found. So let me show you what I mean by that. So we're going to start out the same way that we did previously when we were finding GCFs. So for 18, we can write 18 as 2 times 9, and 2 is prime. 9 is 3 times 3, which are both prime. Let's see, with 30, I'm going to go with 3 and 10, and 3 is prime. And 10 is 2 times 5, and those are both prime. And so we can write 18 as 2 times 3 squared. Notice the exponent. So this is different than what we did before, just a little bit. And then 30 is 2 times 3 times 5. So the first step, it says, let's see, so the LCM is the product of each prime factor found to the highest power found. So what prime factors did we find? 2, 3, and 5. Now we need to use the highest power of each that we found. Well, everything was to the first power except when we were working with 3. Notice we have 3 squared. That would be our highest power of 3. And so we're going to use 3 squared in our LCM. And so we get 90 when you multiply that out. Oops, I'm getting ahead of myself here. All right, so if you think you have that down, I would encourage you to try B and C. All right, so let's see how you did on B. So 6 times 10 is 60. That's one way to factor that. And then 2 times 3 is 6. And those are both prime. For the number 10, 2 times 5 works, and then those are both prime. Now for 108, actually 108, you may or may not recall, is divisible by 12. In fact, it's 9 times 12. Now you may have started with 2 and 56, and that'll work just fine. So 9 we can break down into 3 times 3, and those are both prime. 12 we can break down into 3 times 4. The 3 is prime, and then 4 is 2 times 2, which are both prime. So we can write 60 as 2 squared times 3 times 5. 108 is 2 squared times 3 cubed. So now we need to write down all the prime factors we found. Well, that would be 2, 3, and 5. And use the highest power of each that we found. Well, with 2, they were both squared, so we want to use 2 squared. And for 3, the highest power found was 3 cubed. So we're going to use 2 squared and 3 cubed. So basically what you find is the LCM will always have all the factors that you find in either number. So for example, 60 has 2 factors of 2. We have at least 2 factors of 2. It has 1 factor of 3. We have at least 1 factor of 3. And the same thing for the 5. If you look at 108, it's got 2 factors of 2, which we have, and 3 factors of 3, which we have. And so that's how you find the LCM. If you multiply those out, you get 540. All right, so 16 you can break down into 4 times 4, and we can break that into 2's, and we get 4 2's multiplied there. For 42, we can write that as 7 times 6, and 7's prime. And then 2 times 3 gives us the prime factorization of 6. So 16 is 2 to the 4th, and 42 is 2 times 3 times 7. So our LCM is going to include all 3 of those factors, and we want to use the highest power found. Well, there's only one that has a higher power, and that would be the 2. We're going to use 2 to the 4th. So if you multiply 2 to the 4th times 3 times 7, you should get 336. And you'll find that as the numbers get bigger, this process makes it easier to find your LCM. All right, and that's it for this video.